So we've seen lots of ways that we can flex and scale our families both proportionally and non-proportionally. In this movie, I'd like to tie some of the strategies together and talk about using a scaling factor and multipliers together to give us a little bit more flexibility in how our family behaves. So I'm in a file called Gothic Variable, and it's just a copy of our Gothic arch that we've seen in a few of the previous movies. Currently, the Gothic arch is using a rectangular profile. So it's loaded right here, rectangular profile family. You can see that down here. But there's also a Kaima profile loaded into this family, and it's a version of the Kaima that we built in the previous chapter, but I've added a few features to it. So what I would like to do here is first load that into this arch. So I'm going to select the arch, scroll down over here, and I'm going to change it to the Kaima profile. Now, when I apply that, you're going to see it appears it's a little bit large and its orientation is not quite what we had in mind. So I'm going to take the angle and rotate it 180 degrees. Now, if this box was not here, you can see it if I just sort of click on it. That's basically the orientation that I'm looking for, but the trouble is it's pushing right into the 3D form. So if we wanted to cut a hole in our wall or our surface and embed this molding inside that hole that we cut out, then that would be an appropriate orientation. But if we want it to actually project away from the wall, then we might want to adjust that. Now, we certainly could fiddle around with some of the additional settings here and look at the vertical offset, for example, and we could start manipulating that. But what I'm trying to avoid doing is having to add lots of extra parameters. So I'm going to go with a much simpler solution to solve that problem. And also, we're going to make some other edits to the Kaima profile. So we're going to do both of these directly in this family. So I'm going to right-click Kaima profile here and choose Edit. And that will take me to that family. So to solve the problem I just talked about how it's embedding in the wall, all we need to do is change where the origin point of that family is. So if you look right here, you can see currently the center front back reference plane defines the origin. I'm just going to select this one and tell it to define the origin. That will uncheck from the center front back because you can't have two origins in the same direction. And if we just load this back in and overwrite it, you're going to see that now the form pops up to the surface of the 3D form. So that's the first thing I wanted to look at. Now we're going to work on the proportions of this family because obviously the shape is still a little bit large for our arch. And we saw that we could go in and modify the type properties, but I want to have a little bit more parametric control over that. So if I look at family types for this family, you can see that here under construction, I've already added 3 multiplier parameters. Now, just to review what these are, if I select one of those and click modify, it's a parameter that I just called y_mult, short for multiplier, and its type of parameter is a number parameter. And I just put them under construction just to keep it tidy. You can put them under any grouping that you like. Okay, so I've set the values to 0.8, 0.6, and 0.5 respectively because I'm ultimately going to be using each of these multipliers in formulas to drive these 3 values that we already have here in the family. I need one more parameter, though, to kind of tie everything together. So I'm going to click Add. I'm going to call this parameter Scale Factor. And the type of parameter is going to be a length parameter, actually. Okay, and I'm going to keep that under dimensions. So when I click OK, it will add that scale factor here, and it comes in at 0, and I'm going to set that to 1 unit. I want this scale factor to drive the size of everything else. But I still want to be able to have control over the proportions just in case. So I'm going to start initially by setting formulas that say the scale factor drives everything, but if you want to, then you'll be able to go in and change the multipliers. So all I have to do now is this. For each of these existing dimensions, I'm going to take the scale factor parameter, and I'll just do Control-C to copy it to my clipboard. Come over here, paste it in. Now, if I just pasted that, it would go to 1 because it now equals this. But I want to multiply it. So I'm going to come over here and select y_mult, do Control-C on that. I want to multiply it times y_mult. When I do that, it will gray out y. It's no longer editable, and it will make it 0.8. So it's right back to being the same size that it was a moment ago, but it's ultimately being driven by these 2 parameters, scale factor and the y_mult. Now I'm going to select the whole thing, copy it, paste it, change this to x_mult, paste it again, and change this to depth mult. That grays all of these out. Since they're grayed out and you can't edit them anyway, I usually like to get them out of here, move them up into constraints. So I'll click modify, change that to constraints. And you can see that moves all of those parameters up into the constraints area, which are all being driven by parameters at this point. And now I'm left with my scale factor, which I've just set to 1 right now, and then each of my multipliers. So I'm going to click OK, and I'm going to load this back into my Gothic Arch family. I'm going to overwrite the existing version and its parameter values. All right, let's see what we have now. If I select this object, I still see pretty much the same properties over here. I'm not getting access to that new information. But if I come over here on the project browser, expand the family, right-click on the type, go to Type Properties, and that shows me all of the new parameters that I've added to that family. I'm going to come over here to the Associate Family Parameter button next to Scale Factor, click on that, add a parameter. I'll call that Scale Factor as well. Click OK and OK again to associate that family parameter. That's now linked up. You get the little equal sign to indicate that. And let's click OK. I'm going to leave the multipliers alone for right now. So now at this point, if I want to scale this family proportionally without changing the proportions, I can go to Family Types, and the scale factor is right here. And if I change that number, it will impact the nested profile family. So let's try 0.75 and click Apply. And you can see everything gets a little smaller. Let's try 0.5. Click Apply. Everything gets a little smaller. Notice that the proportions are being maintained, but it's just scaling the whole thing proportionally based on this scale factor property. Now, if you want to, you can come back into here, go back to Type Properties, and link up these additional parameters as well. Or if you don't need to change those as frequently, you can simply modify them here. For example, if I wanted to increase the depth of this profile, I could go to 0.75 on the depth multiplier. When I click OK, the shape will get a little bit deeper, but still maintain the same proportions for the curve. So you're giving yourself the flexibility to be able to change the multipliers on the fly through the type properties, or change the size of the whole thing using the scale factor property. You can do both things directly here from the family. If you want to link up those additional parameters, that's your option as well. But it gives you a great deal more flexibility when building these sort of common profile shapes and allowing you to set them variable so that if you want to use them in different contexts, it's just a matter of dialing in new numbers and you're still using that same basic shape, but you can use it in multiple families that way just by adjusting those little values. So I highly recommend that if you're going to go these approaches and create these standard profile shapes, that you want to go that extra step and add the scale factors and add the multipliers into them so they become much more flexible.